Hello everyone. Today I'll be talking about the states of matter and the changes it undergoes. Also, I'll be talking about how we can classify the matter. I will provide a link in the video description for a clear and clean slides of the topic. First, what is matter? The matter is anything that has a mass and occupies a space. We mean by that things like a chair, a table, a bottle. Also, water inside the bottle will be considered as a matter. There are three states of matter. The first state of matter is the solid state. So in solid state, the particles is organized in a very well compact way and the particles are very close to each other. The second state of matter is the liquid state. In liquid state, the particles have some freedom to move around each other, but still cannot escape the volume of the liquid. In gas state, the particles are moving in all directions and they move freely inside the container or outside the container. The particulate nature of matter. Because matter is made of particles, those particles in each state can be converting into each other by either giving them energy or removing energy. If I have something like solid state and I give it energy, it will be converting into liquid. In that case, I will consider this step to be melting. So if I melt solid, it will be converting into liquid. While if I remove the energy from the liquid, it will be converting into solid in a stage we call it freezing. Liquid also can take energy to convert into gas, and that we will consider to be boiling. As for removing energy from the gas into liquid, I will consider it to be condensation or condensing. If I remove the energy of the gas very quickly without passing into liquid state and just jumping to solid state, in that case I will call this to be deposition. While giving a lot of energy for a solid to convert into gas without passing the liquid state, we will consider it to be sublimation. If I want to compare between the three states of matter, solid, liquid, and gas, if I want to compare, I will be comparing between the particles in each state. So the distance between the particles in case of solid, they are very close together, while in gas, they are further apart. In case of in liquid, they are further apart, and in gas, they are far apart. If I compared between the arrangement of the particles, in case of solid, they are regular. In case of liquid, they are random. Also, in case of gas, they are random. If I compared between the shape, I could see the particles in case of solid are fixed. It have fixed shape, it doesn't change its shape. While in case of gas, they take the shape of the container. So they have no shape. In case of gas, it is also have no fixed shape and it fill the container. If I compared between the volume of solid is fixed. In case of gas, of liquid, it's also fixed. But in case of gas, it's actually not fixed. What I mean by volume, I mean if I have 1 liter of water, if I have this liquid water, I can change the shape by changing the container. I can put it into bottle, or I can put it in a beaker, but it's still 1 liter at the day end, so my volume is still fixed. If I compare between the movement of the particle in case of gas, they move very slow, while they are moving with a higher speed, which I consider to be faster. But in case of liquid, but in case of gas, they move with a very high speed, so they are the fastest. If I compared according to the energy of the particles, the energy of solid particles is very low, while the energy of liquid state is higher, and the energy of gas state is the highest. If I'm comparing according to the forces that hold the particles together, which is the force of attraction. The forces of attraction in case of solid is the strongest. This is why in case of solid you could find them very well compact, have very compact shape, while in case of liquid they are weaker, but in case of gas they are the weakest. So those are how we can compare between the 3 states of matter. Providing the system with energy. If I provide the solid state with energy, it will convert into liquid, and this, like I said before, I will consider it to be melting. So from solid state to liquid state, I have to provide energy. To the system, while in case of liquid to gas, I will have to increase the energy I'm giving to the system. If I moved from gas, if I want to move from gas state into liquid state, I have to take out some energy, take off some energy through condensation, while from liquid to solid, if I wanted to freeze it, this means I have to decrease the energy more. This is why we say that in solid state, the particles have the lowest energy. This is one example of how the matter can change from a state to another. First, if I have a cube of ice, I can convert it into water by giving it some energy that makes the ice melt. So my ice would melt into water. While if I boiled the water, it will be converting into vapor. If I want to move again from the vapor into water, I can condense it. And if I want to move from water state into ice state, I will freeze the water. We could see here, if I have a container, a closed container, this is how I can condense some vapor into the liquid back again. I also can classify the matter according to the purity. If I have pure substance, I can classify it into element, and I can also classify it into compound. If I have impure substance or impure matter, I can consider it to be mixture. In case of element, the element is actually example for that, like in that picture, is the sodium. The sodium have a solid malleable state. So the sodium is considered to be element because I have sodium atoms that just hold together. So it is the similar substance. So I have similar atoms.
Matter is known also to be what we called substance. The substance can be pure or non-pure, which is mixed. If it is in its pure state, it can have two, it can be either element or it can be what we call it compound. In element, it is formed of similar type of atoms while in compound it is made of different type of atoms. The mixed is actually what we call it mixture. The mixed state of matter is a mixture which we consider it either to be homogeneous or heterogeneous. Examples for that, in the first photo we could see an example for sodium atoms connecting together to form a malleable solid rod. It's an element because it is made of the same type of atoms. So sodium atoms is forming this malleable solid rod. In the second photo we could see chlorine gas. In chlorine gas you have two similar atoms connecting together and too many of them, but still they have the same type. They are the same type of atoms, so we will consider them to be element as well. In the third photo we see when reacting sodium with chlorine gas, it forms what we call sodium salt, which is the table salt. It's a crystalline material that is formed of two type of atoms, sodium atoms and the chlorine atoms. Because they are different, there are two different type of atoms, we will call this compound. So the difference between element and the compound, element has the same type of atoms, but compound have different type of atoms. In case of mixture, the mixture is actually composed of materials that mix it together physically, which means I can separate them by physical means. In the first photo, we see a mixture of iron filling with sand. I can separate this mixture physically by using a magnet. If I just put a magnet near the mixture, the iron filling will be attracted to the magnet and I will be left with the sand.
Summary for that. Matter is considered to be anything that occupies space. I can classify matter into mixture or substance, pure substance. If it is mixture, it is either uniformed, have uniform, which I can call it homogeneous, and example for that would be seawater or water plus sugar. If I have non-uniform, this means it is heterogeneous. In that case, it would be non-uniform. Example for that would be iron and sand plus sand. If I have pure substance, this pure substance can be element or it can be a compound. I can convert compound into element by chemical separation. So mixture can be separated by physical means, but compound, if I convert compound into element, it will be separated by chemical means. If I have compound, I have two types of elements, something like H2O. It's a compound that is composed of hydrogen atoms and is composed also of oxygen atoms. While an element, it's the simplest form of matter and it cannot be separated by any chemical means. If I looked at an example for element would be something like chlorine. All elements in periodic table are elements. If I have something like from a periodic table like iron, if I have something like copper, all of those are pure elements. Those are some of the methods that we can separate the mixture. If I have a mixture of two component mixture of water plus sand, I can separate them by filtration. And if I filtrate, I can collect the filtrate and which would be the water, and my residue would be the sand. I also can separate the mixture by distillation, like if I have oil plus water or alcohol plus water, if I boil them, the one with the lower boiling point will just evaporate first, and I can condense it in a column and collect it, and I will be left with the higher boiling point. I also can separate a mixture by chromatography. In liquid chromatography, I have this column that is composed of solid material inside this column, and if I start to add my material, in the first step I will separate some of them, then I will use another type of column to separate another one, and the third into another one. The attraction to the column will be according to the compound I'm separating. So if I'm like separating compounds that can attract to this type of solid, I will be able to collect it in this solid. I can also use gas liquid chromatography for separation of mixture of gas. If I have a gas, I can just separate them according to the boiling point of gases into a column and just collect each gas separately. How to describe properties of matter? I can describe matter physically and chemically. If I looked at the matter physically, if I can physical properties of matter, this means I'm looking at volume, melting point, boiling point. As for chemical properties, it's actually the change that happened to my material, such as if I have boiled egg. So if I have egg and I boiled this egg, a chemical change happened from the liquid egg into a solid boiled egg. The measurable properties of the matter. The matter have extensive properties. These extensive properties will depend on how much material I have or how much the matter is composed of, such as mass and volume. But I have another way of looking at the properties of matter, which is intensive properties. In that case, it will depend on how much matter being considered, something like density and temperature. In the next video, I will show how we can look at each properties and how we can measure the extensive properties of matter. Thank you.